For 1e, we want to find a unit vector in the direction of L2. So the key word here is that it's in the direction of L2. So I need to take the direction vector in my L2 equation, and the direction vector in my L2 equation is -3, 0, -3. So this has a magnitude that is not 1, and what we want to do is right now this is looking something like, I'm just going to draw a random vector, and that's this direction vector. Let's find the magnitude of this vector. So this is the magnitude of -3, 0, -3, which is going to equal the square root of 9, which is -3 squared, plus 0 squared, which is 0, plus -3 squared, which is 9, or the square root of 18. So basically what I just found is that the magnitude of this vector is the square root of 18. I want to scale this thing down so that it has a magnitude of 1. So basically what I'm going to do here is I'm going to have to take every single one of my components and I'm going to have to multiply by 1 over the square root of 18, or 1 over the magnitude in general. So this is basically what I'm going to be multiplying each of the components in my direction vector by. That's how I scale down my direction vector into a unit vector. So let's take 1 over the square root of 18 and let's multiply that by -3, 0, -3. So that's going to equal -3 over the square root of 18, and then 0, and then once again -3 over the square root of 18. I'm going to actually kind of shift back over here because this does simplify a little bit. The square root of 18 has a perfect square in it. That simplifies to 3. Let me just do this over here. The square root of 18 equals 3 root 2. So this is all going to equal -3 over 3 root 2, and then 0, and then once again -3 over 3 root 2. So what's nice about this is that I get some things to reduce. This 3 cancels with this 3. This 3 reduces with this 3. So my final unit vector in the same direction as L2 is -1 over root 2, 0, and -1 over root 2. I could check the magnitude of this by actually finding the magnitude of this direction, and it should come out to be 1, and I believe it actually does. So there's the unit vector.